Good morning, welcome to Current Scum World. In this video, let us study actinometer. What is called chemical actinometer, chemical actinometry, or the experimental setup, etc. Okay, what is the principle of actinometer? It is a simple device which measures the intensity of light radiation using quantum yield and the rate of chemical reaction, or it can be a physical device also to measure the intensity of light radiation emitted. Let us see chemical actinometer. For example, uranyl oxalate chemical actinometer. A chemical actinometer uses a photochemical reaction whose rate can be easily measured, okay, and then whose quantum yield must also be known. One such method, simple method, is uranyl oxalate chemical actinometer. It contains 0.05 molar oxalic acid and 0.01 molar uranyl sulfate in water. It is the mixture, the solution is taken in a cell. When this solution is exposed to light radiation, okay, oxalic acid is decomposed to give CO2, CO and water by photosensitization reaction. Okay, let us see further. Okay, this reaction is called photosensitized reaction because uranyl ion absorbs a photon of light and photoexcited. Okay, this is in the excited state with a large amount of energy. It is highly energetic. Okay, so it causes photosensitized decomposition of oxalic acid. It decomposes this photoexcited uranyl ion, decomposes oxalic acid by breaking this bond to give CO2, CO, water and uranyl ion back in the ground state. Okay, so in this during this process, okay, the oxalic acid concentration is used up. The used up oxalic acid concentration, the consumed oxalic acid concentration, is a measure of intensity of light radiation from the source. Okay, that is how it is how the amount of oxalic acid consumed is obtained. Let us first determine the concentration of oxalic acid without light exposure. Okay, and then the concentration of oxalic acid that remain can be found by titration with the standard KMnO4 solution. Okay, so from these two data, how much amount of oxalic acid concentration is decomposed, that is a measure of intensity of radiation. So intensity observed is directly proportional to oxalic acid reacted. Therefore phi equal to number of moles decomposed reacted divided by number of Einstein observed. Okay, that is quantum yield phi. For this reaction, for these reactions, the quantum yield is 0.6. We know already, it is known, it must be known. Okay, that is equal to number of moles decomposed. For example, let us say 0.0002 molar divided by number of Einstein observed, I naught. Therefore from this we can calculate the intensity of light absorbed or emitted from the source is obtained. Okay, let us now see the experimental setup. It consists of light source, and lens. The lens is used to focus the incident light towards the cell. A monochromator is used to allow only one wavelength of light. A detector, there are two detectors. This detector is used to measure the incident light radiation, intensity of the incident light radiation. The light radiations are allowed to pass through the photochemical cell, and there is a detector where the transmitted light is measured. Okay, this is the experimental setup for chemical actinometer. Thank you for watching. Please share and subscribe. Thank you again. Thank you.